SwayamPrabha. Digital India. Educated India.
Welcome back to this course on product engineering and design thinking. It is today lecture number 35, which is on frugal engineering, which is a disruptive innovation paradigm in product development. Actually, here the frugality means basically what we indicate is primarily is the affordability, and that happens due to the drastic reduction in cost, and therefore that creates a disruption in market, and so it is the cost disruption. So that is the kind of a paradigm that we will take up in our discourse, which is a very important issue today, because the affordability is an extremely important issue, not only for our country, but for all countries and all emerging economies, all countries in the emerging economies, and also a section of people in the developed economies, where affordability is a major issue, which are low income countries or even middle income countries. There, this kind of a product, which is not very expensive, rather inexpensive products are required, and that would meet the need of a large number of people. So we will go directly with this basic premise into today's discussion. So basically what we will do is that we will talk about what are the disruption, how it happens, and then we will talk about the frugal engineering framework, and also we would also see how this frugality, which as I said is very pertinent for the emerging economy countries, which are practically low income and constrained with affordability issues, but then those products can as well be exported to the Western countries, the developed countries, developed economic markets, where to cater to a section of people there whose income is also not high, and that kind of innovation would be called reverse innovation. Particularly here, I would like to make a point here that innovation per se, it is as the common belief or the notion goes, is that it is a thing that happens in the developed world, in the developed market. A product is developed, created, and then it is sent to other countries, emerging economy countries. The innovation goes out. So basically it is kind of a trickle down effect, trickle down of innovation from the developed world to the emerging economy world. So or which we call global south, that is coming to the global south. So that that is the trickle down. Innovation is trickle down. What in reverse innovation we are saying is that certain innovation which is possible in emerging economy, and those can be exported to the even developed countries, and that is for a section of people which would be benefiting from this kind of product, which has high affordability, and this model therefore will be trickle up. Earlier it was a trickle down, now reverse innovation will be trickle up, that it would be going from the emerging economy to the developed market. And well, then we would be talking about the Therefore, how such design is possible? In frugal design, there must be certain value propositions. We will discuss what are those value propositions involved in frugal design, and then we would discuss what the tools available, or and how what the tools we can use effectively in frugal engineering. But let me tell you that there are many tools which normally are used for general product engineering and product development, product design. They can very well be used for frugal engineering, absolutely, and there is no bar of using any tool. But there are certain tools specifically which are very pertinent and which gives great advantage in terms of cost reduction particularly. We'll talk about those. First we will go to the disruption issue, that as we said that there are two kinds of disruption. One is the low end disruption, which is our current focus. One, when a venture enters at the low end of the market, offering products with good enough quality. Good enough means which satisfies the need. It may not be the best, because best may need enough cash outlay. For example, if I have to travel and stay in a hotel, I need not be in a 7-star hotel all the time. I may be stay in a place which is economic. It may be a budget hotel. So also you have seen the airlines now, no frills, just for the cost of flying, no foods, nothing, all have to be purchased. So those are the models, those are frugal models. Now this good enough quality, which we call copacetic, this is actually our term that we have used. In fact, we have made a publication with this term, which is coming up in a book being published by Springer. Here the quality at a low price and accepting low profit. But then that, though it is a low profit per unit, but since this demand will be more because of it is affordable, then it will be made up from the volume. And new market disruption is when ventures create a new segment in existing market. That also is possible, and then they grow into this. So one thing I would like to tell you, many people somehow talk about frugal engineering. I mean, other terminologies are used also. Frugal innovation, frugal design, those are fine. But some people say call it jugaad innovation, which we actually do not think it's fitting, because it actually conveys message, a poor connotation about quality, and most importantly, it is not sustainable. So if something is not sustainable, we will not discuss. So jugaad is not our scope, and we will not discuss. And when we are saying frugal, we are not by any chance meaning it jugaad. I am clarifying at the beginning, because in literature you will see that plenty of references like this, but for our requirement and purpose, we simply will not touch it. The spacecraft which has gone to Mars, it cannot be sent with a jugaad method or mentality. It is actually frugally done with systematic engineering for cost reduction. All right. So then we move on to the frugal engineering term. Actually, the term was coined by Carlos Ghosn, who got inspiration from the design of the car Tata Nano, and he coined the term that frugal engineering. Andrea Bensick, though this Tata Nano perhaps has not done very well, but then the idea is that philosophy, that principle or precepts are actually have become very important, and those are being practiced by other auto manufacturers, and it has been reported by Andrea Bensick in one of his articles in 2016. And so the Western R&D model is being reviewed by, and this kind of approach is being considered. Here, let me tell you, when we are saying cost reduction, it is just not simply doing something which should be done, but we are not doing it. It is not arbitrary cost reduction. So it is, there is a purpose. Purpose is that it is actually defeaturing or removing the non-vital features, because in products often we find that, particularly in the Western world, when the new products are launched, they claim that okay, we are adding this feature, the cost is up and all that, but then that those becomes expensive models, but then the new features are coming, but many of those features are not used. Who uses a car here or in many parts of the world which can run at 200 kilometers per hour? But that is the design that has been made. People are buying that car, but no one is running. Do you think in most of the countries the road condition is that it can be used? No. So defeaturing is important, and by defeaturing, by actually focusing on the core features, which are essential features, vital features, if we focus on that and only attend to that, address them, then the cost drastically goes down. So that is the objective, but under no circumstances it means that though it is being made cheaper, the quality is being compromised. No, rather it may be that since we are reducing the number of features, complexity is being reduced, and then its performance is going up, so quality or reliability is going up. That also is possible. However, I mean, if for a say 50% reduction in cost, if say 5% quality is or reliability is compromised, maybe a group of people still would accept that. Um, uh, so here the idea is that increase in demand because of this affordability advantage would increase the number, and that will bring economies of scale, and that is what is the important. By the way, I would tell you, the Carlos Ghosn, I say the Carlos Ghosn was the chief executive officer of Renault Nissan, which is the leading auto manufacturing company in the world. So uh, what we need now, when we are talking all these, we need to understand, okay, fine, I mean, we are talking about volume, etc., but how much is the volume? Where is the market? Do we have that much of volume? Do we have so much of demand? That's the question. So let us examine them now, whether there is a demand or not. But before we proceed to that, so we are talking about, when we are talking about demand, we are talking about the market. So here, before moving on to the exact demand analysis or finding, we would just like to touch on this, because as we know that design, technology, and of course the business, the entrepreneurs we are talking about, as I said, how big is the market for frugal products? So because the market is a component, when these four intersects, four aspect intersects, then the magic happens. Then the a real gain happens, the best fit happens. So uh, you can see the intersection, um, uh, which is to be produced without supererogatory or over engineered features, and that is where the marvel occurs. Now, so if that is the case, we have to examine the market. What is the market? How big is the market? As we have just now started discussing. So here we see that design, technology, market. So we will have to touch. We said that we will talk about the frugal engineering, the technology aspect, the design, frugal design aspect. So we will discuss them. Now, quickly, I mean, now about the market, as I said, the market is that the emerging economy countries, total if you put together with the world, is having a customer base of say more than 5 billion. Imagine, out of a current world population of 8 billion. And this is based on a survey done few years back by PwC. In at that time when the population was about 7 billion, it was found that the middle was 4 billion, and if we take 1 more billion at the lower end, so 5 billion. So it is a large volume of customer. So if we can do something here, then there is no dearth of business. In fact, the Western companies are actually trying to target this market. And if I will give you quickly several examples where you will find particularly the world-class companies, the world leaders are actually entering into this area of business, this frugal products, and to capture this market, to capture this big market. Now, here, so the affordability, as I said, is important, but also we would not lose sight on the quality, because the quality is the fulcrum. And we have just touched upon the reverse innovation part. If we consider that, then the market can be even more in size. All right, so quickly our coverage on reverse innovation. As I have already said, that reverse innovation happens when from emerging economy it goes to developed markets, and this frugal innovation goes into developed markets. And it is to understand that frugal innovation is rooted in two things. One is the frugal engineering, that methodology that we will be discussing, and also the local need, that indigenous need-based ideation. That how we have written design thinking, how the empathy for that need is important, how it is addressed. So the indigenous need-based ideation and frugal engineering, these two creates frugal innovation, and there some of those innovations goes into the reverse innovation. Maybe with some additional of one or two more features, may not be all, can be candidate for reverse innovation to suit the requirement of those advanced countries. And on the left side, you will find that micro level, macro level, etc., which means the national level or regional level economy vis-a-vis individual's capacity. So that happens in both this thing, economies, both in emerging economies as well as developed market, which influences this frugal engineering and needs, etc., which we can see here. We need not read much into this, because we have already understood what reverse engineering, reverse innovation is. That is what is the forte. So our focus is that if we can do a good frugal engineering job and develop a good frugal product, then there is a scope of reverse innovation, that is export. Basically, that export brings foreign currency. That is important. That is, and also it would make many import substitution if you very carefully look at it, and that is what is today's India's need. And the Atmanirbhar Bharat that we are talking about actually will come from these efforts. So frugal innovation, frugal engineering, and through that, if we can reach reverse innovation on all, it is a route to Atmanirbhar Bharat or self-reliant India. All right, so here very quickly we would see that the frugal design thinking has the features which are very easily understandable. I will not go into the detail, and they are affordable, which means price point is low, cost of ownership is low. We will go into the detail of this some. Manufacturable, which is easy to manufacture and cost economically it can be manufactured. User centric, you remember that we did in design thinking, which is user friendly. Functional, the functional means its performance should be good, reliable, and good quality functions. Indigenously, it should be sourced. So if something is not imported or brought from elsewhere, can be locally made with local resources. It is always cheaper. So local, and finally sustainable, that it should be socially relevant, it should be economical, and it should be eco-friendly. It is not that we are making something cheap, therefore it would pollute the environment, it would create more emission, or it would do certain effluent generation. So that is not what is intended. So these are the aspects that we have to keep in mind in the frugal design approach. here it is nothing but a list of certain examples. So here, I mean, what basically in this slide I am going to tell you is that frugal design space is, I mean, very wide. I mean, starting from pen to write with or pencil to write with, to aeroplane or to ship or to even spacecraft, all are coming under the purview of this frugal engineering. I'll tell you why. So here, that is the list, say from spacecraft to small refrigerator, from say car. Now we are talking about car. Nano principle is now used by Quid or Logan to do cost reductions. From the car to incubators for infants, from electrocardiogram to scanners, ultrasonic scanners, for X-ray machine to prosthetic limb, all everywhere the frugal engineering principle or design principles can be used. Also in modern cases with frugal innovation is possible with IoT or artificial intelligence, which saves cost and time. Well, also there is a concept called bricolage, which means not to invent new things, but there are many things which you can assemble and assimilate. It will give a very useful product. So you remember we were talking about the design driven innovation. So in the course of design driven innovation, this particular aspect will be highlighted, which talks about that how just not going chasing technology, how by doing design, good design, this good product can be realized. Now as I said, I am moving on to, but I will not spend any time on this because it is basically intended for you to look at later, to look at the examples, because there are many examples I have presented. But in short, what I'll tell you is all frugal, because say for example, instead of computer, they are using for this electrocardiogram machine by General Electric, they are using printer, which is used for bus ticket printing. I'm giving one example. So they have been able to reduce the cost by 10 times, which original cost was $10,000 is now as $1,000, and it is being used in several rural and semi-urban areas in India, which was developed here. I will just keep on telling the examples, details you may study, but this is to give you the idea of what frugal engineering is, examples, that's all. I mean, I cannot go into all the detail here, obviously you don't expect that, and that is not the purpose of today's discussion. Examples are many, thousands. So I am giving you some of the examples, like said, here is a tractor, which is very low cost tractor, would cost 2 lakhs rupees, which has been developed by CMRI, Central Mechanical Engineering Research Institute, which is a CSIR organization, and that is used for, that's called Krishi Shakti, and that is used for the agricultural purpose and for farming as well as transporting, etc. I'm just giving you the examples. Just see what is the scope and domain. See here the Siemens Multix DR X-ray machine. What they have done is, earlier if you had noticed that the X-ray rooms were having huge structure beams and all, so the cost of infrastructure was really very high. Instead, what they did was a floor mounted device which reduced the cost to a great extent, and the digital X-ray machine with high level clinical flexibility, it is possible, excellent image quality, and the cost is drastically reduced. It is actually 1/3 the total cost if you look at. So imagine when I'm giving you certain examples of frugal engineered products. One is the fetal heart monitor, which is also by Siemens. And by the way, I mean, I would like to tell you that just for Siemens, they assess their for their this frugal category product has a market of 200 billion US dollar. They call it smart. Smart in the sense that it is simple, maintenance friendly, affordable, reliable, and timely to market. They call it smart. So look at the portfolio, how big the market is. So if anyone is trying to do it here, so that would certainly help them a lot, and that reduce the cost to half. 50% is the cost. So it is a cost disruption in the fetal heart monitor where they are using microphones. So for example, instead of ultrasound technology. So but just by using the available technology, which is much cheaper, much inexpensive, the cost has been reduced drastically. In coming to the prosthetics, here you see that perhaps you all have heard about Jaipur leg or Jaipur foot, which is to use prosthetics. On the left side, you see that young boy has lost his leg and therefore is using this prosthetic. And possibly you may recognize the lady who is in the middle, who is a very famous dancer, but she dances with a wooden leg. Sudha Chandran, if you remember her, and see the quality of the prosthetic is so good that one can dance using that prosthetic limb. So this is one great example. The credit goes to Dr. Shetty and Master Ramchandra Sharma, who actually developed this, and that has changed, that has created a revolution in prosthetics. That's absolutely wonderful, fascinating. Um, uh, you study those details. Now, babies are in particularly developing countries are suffering from different many inadequacies, that they don't have good incubators and all. So if there are not good incubators, how to make them work, and how the babies would survive. Embrace had the name of the product that came out at Stanford, which is an infant warmer, which uses a kind of a wax kind of a material, which is a basically it is a phase change material that you use, and when it melts, then it can hold the temperature for pretty long time, maybe for 8 hours or so, and the temperature can be reached at say 98 degree Fahrenheit. So in that the babies can survive. So these are low cost development, but that is immensely impactful. It has huge impact. You can see, I mean, these are certain examples. This is another example of a Chinese X-ray machine. What is the example is that, see, in a good, I mean, a full-fledged X-ray machine will have the capability to do all kinds of X-rays, but they found that majority of the X-rays are chest X-rays. So at least for chest X-rays, they could find out a cheaper solution. How they had technology available with their parent company, which is an aerospace manufacturing company. That was underused, was not much used. They took that and they used it for X-ray development, X-ray machine development purpose. So it is a digital direct X-ray system, online scanning. They have developed this, but it can do only chest X-ray. But the cost, you see that it has become $20,000, and the Siemens and the Philips and the General Electric cost used to be $150,000. So their focus was problem, that what is exactly the problem, that is the chest X-ray is the maximal one. Solution of technology, that they used a cheap available technology, they didn't go for a high and sophisticated technology, and the result is that they could capture 50% of the market in that domain, and General Electric had to cut down its price to half, and Philips simply left that competition. They could not survive. Tata Nano, I don't want to go into further detail. Perhaps you all know the story of Tata Nano. being in India. But then I have just jotted down many things. What the Tata Nano features are, where, say for example, they have used one wiper instead of two, the two-cylinder petrol engine instead of four, say no power steering or air conditioning, no anti-lock brakes, not airbags. So by that, the common people could afford. Now that the principle, I'm again telling you, though Tata Nano has not prospered for different reasons, but new variants are coming, but the philosophy is traveling worldwide. I have already referred that this has been said that the Kwid and Logan and many car companies are using that concept and precepts. Here, I would still like to present one more example, which is the Professor Amos Winter of MIT. He comes to India on a regular basis, and the Global Engineering Research Lab here is working on this, which is creating all-terrain wheelchair for Indian people. So this is a very important problem that he's trying to solve, because the rural roads and are not very even and good. So if it can travel in all conditions, that would be very helpful for people. You can look at the picture how in rural India that is being tried and done. So this is, and just quickly two more Indian example. One is Chotocool, that refrigerator which doesn't require any compressor. It works with a fan. That fan is used in a computer, and that cools that this through evaporation and all. You see that lady is carrying that refrigerator on her head, so you can understand how small it is. So that is one example, and it serves the purpose. But it is here it can keep that thing for, say, maybe a couple of days, which is absolutely necessary for just saving fruit and other things. Otherwise, it would be food waste. Akash tablet, many of you already know that it is a low-cost tablet that was created in India by a company called Data Wind and provided by Government of India, which actually helped many students. Now, coming to the value proposition. These are the main or core things that we will be discussing, and as a designer, this is a thing that one should focus on. It is that it should be value driven. That is first is the upfront pay. The price is low. That the first price also is low, and then also the total cost of possession also is low, or the total cost of ownership also is called. That is the price plus maintenance and repair plus consumption. If whatever, say, it may be fuel, it may be electricity. So all these, through their life cycle, that cost should be less, and also it should be eco-friendly, because if it creates emissions, so that also involves certain cost of removing effluents and all. Optimize performance with robustness. This is very important, because in our kind of economy and country where there are huge variation, power cuts are happening, voltage fluctuations are happening, temperature variation from one place to another is extreme, dust, etc. is there. So it, in spite of all this, it should work. So that is one thing. Complexity reduction is important. Too much of complex, like say remote buttons. So there are many buttons. People, most of them do not know which button works for what. So the simplicity can be introduced. It will be very useful. So, and that is called elegant simplicity. It should aesthetically be good, but it should be user friendly and elegant simplicity. And finally, as I said, economies of scale, because of the demand will go up, and from that the revenue and return and profit will come. Affordable excellence results from the unique value proposition. I would skip this slide much, because all those things I have already explained, and it is written there in detail. As I have already told you, those things I have explained, those are all written here, like say fuel and maintenance and all those things are written. So you read that in your accordingly. Like say for example, fan or refrigerator that consumes electricity car consumes fuel, and so on and so forth. We will go to the almost towards the end, that says that what are the therefore tools we should use to do this. There are certain tools which are very useful. Out of many tools of product engineering, one is the value engineering, the fast diagram mostly, which we have already been discussed in module 2 and lecture number 10. If you look at the slide number 7 to 15, you will find the discussion on value engineering, so I am not repeating it here. Similarly, design for manufacturing or design for manufacturing and assembly, this was discussed in module 6, lecture number 27, slide number 7 to 19. Failure mode and effect analysis, FMEA, that was discussed in module 6, lecture 30, slide number 7 to 12. There are two other important tools which are called trees method, though briefly it was touched in module 1, but a quick familiarization is required. I will just do that shortly. And also another tool called reverse engineering, not reverse innovation. Earlier I have spoken about reverse innovation, which is a different thing. Reverse engineering is another thing which I will explain. Don't confuse between reverse innovation and reverse engineering. These are two different things. And quickly, so we will nearly complete with these two tools. But that would be just a glance. Right now, because there are, you can understand each tool, discussing each tool would take a huge long time, and that may be a course. So if needed, you can learn that later. But here my job is to tell you. I thought that is important for you to know as a designer, as an engineer, if you want to use it, where to go, what kind of things you need, and where it is available, and how can it be used, and what is the application. So with that idea, I am keeping the trees method. The first is, you see that the concept is that if you have a problem, there is a solution in practically a large number of cases. Somewhere somebody has already solved it. May not be for exactly your problem, but for some other problem, but you can use that solution for your problem. That's a beautiful observation by Altshuler. Here the idea is that so it is not, if you have a problem, here you see the first diagram, if you see inventive problem and solution, so it is a trial and error. No trial and error. What rather can be done is to make it economic, that inventive problem can be converted to a trees problem. That means to a general problem, from a specific problem to a general problem. And for a general problem, there are too many problems. General problem, there may be similar many problems, and there are many solutions. So one of those problems will have some kind of a solution, and out of those solutions you can pick your solution. So what I am saying is, from a specific problem you are going to a host of problems, which we are called general problem, or a host of large number of problems, and from similar problems. So, and how the similar problems have been solved, and one of those solutions may be useful for you. That's the methodology of trees, which has gained huge popularity. And here I am not going into the details now, but there is a thing called contradiction. That is very important. Say contradiction means if I want to say, for example, increase strength of a material, of a component, then its length or diameter is to increase. So when I am trying to do some good here, some worse is happening elsewhere. Weight is increasing, or volume is increasing, or material consumption is increasing. So there is a contradiction matrix which is on the top right. I am just showing you the glimpse. That's why I have written at a glance. I am nowhere telling you that we are discussing in detail. I am just giving you the impression what it works, because whenever you need, you can now go back to find out where to use, how to use. Now here there are 39 engineering parameters. Now, the engineering parameters, if you Google, you will find there are 39 different engineering parameters, and there are already established, it's already established solution, 40 solutions are available. And so here you see the idea is that in the contradiction matrix you would find that inside boxes there are certain numbers written. What those numbers are? Those are the solution numbers. So the solutions are provided, 40 solutions are provided in a serial number 1 to 40. So say if on the first row, if we see the third column, 15, 8, 29, 34, it means weight of moving object. If we try to improve, what worsens is the length of moving object. So if we try to reduce, something increases. So 15, 8, 29 and 34, that means these are the serial numbers of the solution through which the problem can be solved. So it is a systematic problem solving approach. At this stage I will not go beyond this, because this contradiction on the left side, you would see that this is a technical contradiction and physical contradiction. Say something to be to be increased to do that, but then if it increases, then it is actually to be shortened. So its length is, so physically it is creating a contradiction. So at this stage I think it is not to be explored any further unless you come across a problem. Otherwise, on trees there are several discourses, maybe there are many lectures on discourses on trees itself. So and also reverse engineering itself. So I would rather touch upon these concepts and move on. So reverse engineering is what? What is forward engineering? Forward engineering is that we create a concept, as we were discussing. From that we go to the prototype development and then product. Reverse engineering says that no, already a product is available. Say this mouse is available. This mouse is available. So I want to create a mouse. So how do I create? If I can reverse engineer this, I can come to the diagram of this. Today I don't have the drawing of this. I don't have the drawing of the mouse. But this mouse, if I do a reverse engineering, say using a laser scanning system, and if I can capture that cloud data and through that system that is available here, so if we can capture and put it as a CAD drawing. So from the product we go back to the drawing, and the purpose is just not to do a copy. The purpose is, if we want to save time, quickly develop something, already if something is available in the market, competitors do that. So pick up something, look at what is the diagram, but then try to improve upon it. That's the most important thing, which is called re-engineering. Re-engineering is very important, that just not copy it, go from the product to the drawing, then improve. And that is exactly what is shown here on the diagram. On the left you would see the physical model, that the object that I was showing as mouse, the physical object is digitized by the coordinate measuring machine, CMM, which is laser based or optical based. It can be tactile, it may be non-tactile, both type. It can touch, or say for a laser it doesn't have to touch. And so it goes into the data analysis and processing system. And here I was talking about the design and modify. On that you make the modification, that whatever the drawing finally comes out from the product from the product we are going back to the drawing. It is just reverse. You see, normally we go from drawing to the product, but here we are going to the drawing from the product. And then after doing the re-engineering, modification, improvement and all, we again send back to the system for manufacturing, that improved version, which is the NC machine or CNC machine, as you know, and then the prototype is created. So it is just the reverse, and it is a one good way. And all the countries who have progressed a lot in developing products, be it Japan, be it China, you perhaps know that they did huge reverse engineering in their industries and products they brought out. So I would conclude today's discussion practically saying that this, you see that it is the Mars orbiting mission, ISRO's Frugal MOM, it is called Frugal MOM, Mars orbiting mission, which cost 1/10 of the cost of MAVEN created by NASA. And what they did is that instead of directly a slingshot from Earth to Mars, they actually used that technology of moving it around the Earth for about a month and then went there, so that fuel consumption was less. That was the technology. I'm not going into the detail of the technology, but I am saying the concept. And very interestingly, that it was supposed to be there only for 6 months, but trust me, the quality is so good. I mean, quality also has to be good. As I am speaking now, as we are discussing, it is still up there, orbiting around Mars. The quality is so good, and the report tells us that it will be there for some more time. It is very fascinating. So it is a Frugal engineered product. Mangalayan it is called. So I would conclude saying that, so we understand that this is a very important thing for emerging economy markets. This discourse deals with innovation and cost disruption, create affordable products based on precepts on frugal engineering and innovation. It discusses the interaction of design, technology, business, market for ideal fit. The aspects of frugal engineering based reverse innovation is also delineated here. The discussion moves to the frugal design aspects for unique value proposition we have discussed. A number of examples have been presented for a comprehensive understanding, and we are close the discussion with the pertinent tools. And this is the reference. So I'm sure that that you have been inspired and motivated with this kind of work that our countrymen require, and also a huge population in the world requires, more than 5 billion, and I'm sure that you would be interested to work for them, and this discourse certainly would help you. With that hope, I would hope that I would expect that some of you at least will try a few things to develop a model or a product. Thank you very much for your patient hearing, and I'm sure that you will do good with this. Thank you very much.